In this video, we're going to continue talking about impulse, and I'm actually going to show you how to solve word problems that ask you to find impulse or different parts of the impulse problem. So let's get started with these calculations. Alright, so first example. An 8 Newton force acts upon an object for 5 seconds. What impulse is given to this object? So, impulse. Remember, we have this long equation where everything is equal to each other, right? So we need to figure out what exactly were provided in the problem, because I know in the problem we were not given momentum, mass, velocity, force, and time. We're only given 2 things, right? We're given 8 newtons and 5 seconds. So we know that the force is 8 newtons, and we know that the time is 5 seconds. Our unknowns, well, it's asking us what is the impulse. So remember, impulse is J, so we need to be looking for J. And we're not going to use this entire equation because that just wouldn't work, but we can select what we have. So what I mean by that is we have the force and the time, so we can definitely use this part of the equation. And then we're solving for impulse, so here's impulse. So we're actually going to be doing impulse equals force times time. Now we just need to substitute, so impulse equals the force was 8 newtons, and the time is 5 seconds. 5 times 8 is 40, and remember it's newtons times seconds for our units. Alright, perfect. So, next one. A ball changes velocity from 20 meters per second to 30 meters per second. If it has a mass of 5 kilograms, what impulse was necessary to cause this change? So again, we need to first write down our givens. So it goes from 20 meters per second. So that's the starting velocity. So that means it's the initial velocity is 20 meters per second to 30 meters per second. So that's the final velocity, VF. And we also know that the mass of the ball is 5 kilograms. Okay, and it's asking us for impulse, so that's our unknown, J impulse. So we need to figure out which part of this equation up here are we actually going to be using. Well, we know that the change in velocity and the mass, so that's this part of the equation. And then we need to find the impulse, so we're going to be looking at impulse. So J equals M times the change in velocity. And remember, the change in velocity just means that it's going to be impulse times equals mass times VF minus VI. Remember that change in velocity is the same thing as final velocity minus initial velocity. Now we just need to substitute. So impulse equals the mass was 5 kilograms times the final velocity was 30 minus the initial velocity was 20 meters per second. So that is going to give us 5 times 10, so our impulse is 50. So our answer is 50 newtons times seconds. Alright, last one. How long would it take a 5 Newton force, so 5 newtons of force is being applied, to change the velocity from 20 to 30 meters per second of the 5 kilogram ball? So we're given more information for this one. So we're given that the force is 5 newtons. We know that the initial velocity, again, is 20 meters per second. We know that the final velocity is 30 meters per second. We know that the mass of the ball is still 5 kilograms. Our unknown this time is different. It's not asking us to find the impulse. It's asking how long. So how long, remember, is time. So we need to figure out how to use this equation to solve for time. Okay, so we're given force, we're given mass, we're given the change in velocity. So we can use this part of the equation and solve for time there. So you can plug in and then solve for time, or you can rearrange it before you get started. So I know that I want time on a side by itself. So what I could do is just go ahead and set up my equation to divide by force and divide by force. The forces cancel out on the right-hand side. So you would have mass times the change in velocity divided by force is equal to the time. So you could definitely do it that way, or you can just write down your equation and substitute your answers in. So the equation is mass times the change of velocity is equal to force times time. Now we're going to substitute. So the mass was 5. The change in velocity was 30 minus 20. Because remember, change in velocity means that we're going to be doing final velocity minus initial velocity equals 5t times t. Okay, and I left out the units just for the sake of me writing on a laptop screen, but you're more than welcome to write it in your notes and include the units. So this would be kilograms, this would be meters per second, this is 5 newtons. So you're definitely more than welcome to include your units. So I have 5 times 10, so we have 50 equals 5t. We need to get t on a side by itself, so we need to divide by 5. That cancels that out. You have to do it on both sides. So we have t equals 10. And we know that we were looking for time, and all of our units are in seconds. Concerning time is in seconds, so 10 seconds is our answer. All right, hope that helps. If you have more questions, definitely ask for help. Thanks for watching.